So we are going to solve the Leetcode daily problem, which is the maximum product of splitting the binary tree. Given the root of a binary tree, split the binary tree into two trees by removing one edge such that the product of the sum of the subtree is maximum. Okay, return the maximum product return the maximum product of the sum of the subtree. Since the answer may be too large, return modulo of this one. Note that to maximize the answer before taking the mod, not after it. Note that maximize. Okay, okay. So they give you a binary tree where you need to find two trees whose sum product is maximum, and you need to delete one edge so we can form the two trees by that deleting the one. So they give you this tree. So how we can do that? So first thing that we can do, we can check the sum of the right part and the sum of the left part. Okay, solve this. One, take make the sum of that. Okay, in the first iteration, we are going to find the total sum. In the next iteration, we are going to do like we are taking a running a binary loop where we reach here. Then we will check at the is the left node of the leaf node is present or not. If it is not present, then we go for the right. If it is not, then we are going to sum that, and it is gives the zero. So we are going to subtract that. So we have the zero and we have the total sum. So it gives you zero. So we go to the next node when we are going to return the 4 from this side and returning the 5 from this side. So we will get the 9 and we are going to add that add this element also. Okay, we did that. Then we go for the next. Okay, and what we are going to check, uh, left node, right node, then it will go into 0. So 0 0. So we go for the here and it will be giving you 5. Okay, it will giving you 5 and it will giving you the 4. Okay, so it will give you the 4 where it will give you the 5. And what you are going to do, you are going to subtract that values from the total sum and going to multiply that 4 with the subtracted value. Similarly, you are going to do for this also. Okay, and we are going to store the answer. Then we reach to the that point and we reach here. Okay, so this what we are going to do. We are doing the operation for this. So we are going to subtract this from the total sum, and we are going to return total from here. Okay. After that, similarly, we are going to do from this. So the first thing that we need to do is the finding the total sum of a binary tree. So how we can find that? Find the total sum. We can run a loop, which is the total, which will be taking the parameter as total node, which is root, and we are going to check if root is equal to null ptr, then we are going to return 0. Okay. Okay, and what we are going to do, we are going to adding that, and we are going to first thing that we are going to do is adding that value into the sum. Okay, and you are going to return root dot value plus f of root dot left plus root total root dot right. Okay, so we will check. It will first go there, and it will check that go for the left road node, and then it's going to uh, 4. There is a no any node present, so it's going to return the 4. It's going to check at right, and there is a no any node is present, so it's going to return 0. So, and what the root value, which is 4, so this node is going to return the 4. Similarly, you go for the left also. After left, you will go for the right for this node, and you will check for this also. So you will get the int total sum, which is equal to total, and which is taking the root. Okay, what is the next step that we are going to do? In that, we are taking the function, creating a function which will be in f. We will do implementation next. We got the total value. Now we are going to travel it through the um, okay, through complete tree. We have the total. So similar like total, we are again finding the total also. Um, hmm. And there is a one of the brute solution can be present that you can traverse from each node, like you are now here, so you can use total for that. Okay, it will give you the sum value, which is the sum of the total of that child. While if when you visit to the second level node, which is 2, then you will get the total sum of the 2 as a root. Okay, and you are going to subtract that from the total value, and you will get uh, one value, this one, and second value is this. So you are going to do multiplication as per that. So that can be the brute force solution. And the next solution that we can do, which is the traveling like this to the complete, then we will go to return and nothing is present on, then we are going to return that. Then we got the 4, we come to the 4. So what we are going to do in that, so we are taking the node which is root. Okay, then we are going to check if root is equal to null ptr, which is the base case, then we are going to return 0. Okay, for the next step is we are going to find out what's the value I will get from the left and right. Okay, and left, which will be f f root left. Okay, and int right means was the sum of the root, was the value sum of the nodes present at the left side, and what's the sum of the nodes present at the right side. Okay, which is, sorry, int right is equal to f root right. Okay, so we got left value and right value. Okay, so we are going to add it int actual value is equal to left plus right plus root that value. Okay, okay, okay. What if we are doing that also now? So we have the separate files. No need to subtract left. Okay, so we got the value. Then we are going to what we are can do, which is int total value and then we got the value. Then we are just taking the maximum of that, which will be max answer, and which is int answer. Initially it is the int main. Okay, and then what you are going to do is answer is equal to max of answer total value minus value total value minus value into value. We are going to mod that. Okay. In temp it will be modulo of e1 e4 9 plus 7. Okay, which will be modulo by mod which is temp, and what you are going to return, you are going to return the value only, and you got the total sum, and you are doing the function like add, which will be taking a total root and total sum, and you are going to return that. Okay, okay, we will check again. Mistake. Okay, 36 was. Hmm? Okay, so it is giving me wrong answer. We will diagnose that. Uh, so first we are going to see out the total sum. Okay, okay. So it is just giving me total sum only. Okay, the total sum is correct. Okay, so the problem is about the f function and what it is doing. Okay, so what actually happening we will see. Okay, first we need to like this. Even though it is giving me the same value as the total sum, even though I'm multiplying it. Let's what's the reason behind that? You got the left value, you got the right value, you are taking the value also. So 5 total value you are going to subtract that, which will be in the first case Okay, so can we make the out value in that? Okay, just remove this one. We will check. First, you need to give the 4. Okay, it gives you 4, then gives 5, then gives you 11. Okay, okay, taking the whole things. So 4, then he's giving you 5. Fuck yeah, what you are doing? Returning answer. There is no problem. Just return answer. Hmm. So runtime integer overflow. Type int. So we need to mod the correct like 10 is 7. 1 E9 plus 7. Even though it is giving the problem while the storing the temp as the temp is overflowing the value. So can we put long and then you can just check is that giving the correct answer. Okay, it will give false because we are going to maximize the temp with that, so that's not going to help. We can do like that, so we can find the interval temp 1 which will be total value minus well, which is mod, then int temp2 which will be temp1 star val modulo mod, and what you are going to do, just temp2 L नमस्कार
इकडे महेशपूर येतात
होतं किती
हम्म?
होतं किती
इथं कुठे तर मी गेलो कपडे
हम्म?
हातपाय धुवून गेलो मी हातपाय धुवून गेलो तेव्हा
So they mention that. Hmm. So we can check whether it's, why it is giving the problem. Okay, they mentioned that you need to use long everywhere. Long 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 long. Okay, then we need to maximize and minimum. Okay,